at evaluating trig with special triangles. So we have a trig equation, and one way you can do this, if your calculator calculates cosecant and sine, you can kind of plug that all in, but your teacher might want you to have the exact values as you go through it or something like that, okay? And when you need an exact value, some calculators will actually turn things into radicals and fractions depending how good yours is. But if they don't, they'll just give you like a very long repeating decimal. So if we're going to get the exact value, we got to use some special triangles. So the first thing we have to remember is what the values of our special triangles are, okay? Yeah. So one of them is, they're both 90-degree angles. He's okay. With two 45s. And if you recall, what that means is you have two sides that are similar because it's an isosceles triangle, and then the hypotenuse of it is root 2. The other special triangle is set up like this, where you have a 30, a 60, and a 90 degrees for angles. So we have 90. This looks like the smaller, so I'm going to call it 30 and 60. And sometimes it can be hard to recall which is which here. And what it is a 1, 2, 3 ratio. 1 is the smallest side, so because that's opposite of 30, we know that that's the shortest side. 2 is actually the hypotenuse, and root 3 is a value that's in between 1 and 2, so we can assume that's where the 60 is, okay? So then what we need to do is we need to know what cosecant, sine, cosine, tangent, what all those things are equal to. We know that a sine ratio is the opposite over hypotenuse, okay? And cosecant. Do you know what cosecant is equal to as a ratio?
Is it the opposite of cos? Or?
Cos would be secant.
Okay.
Yeah.
So it's
of sine, yeah.
Over
exactly. So it's hypotenuse over the opposite. Good. So then what we got to do is we got to locate these angles in our special triangles, and then locate what the opposite and hypotenuse is, and the hypotenuse and the opposite is. Okay, it's upstairs. So when we do that, we're going to highlight, first of all, we find one of them is 60 degrees. So if this is our 60 degrees, sine, because that's our value here, sine, would be the opposite over the hypotenuse. So in other words, sine 60 is equal to root 3 over 2. And that's what I mean by exact values. Okay, so we'll move this down so we have some room. We have some extra help from him right there. So this is root 3 over 2. And that's still times that coefficient. Think of that like a coefficient of 3 in front. The other idea is cosecant. So one of the angles is 45. So it doesn't matter which 45 you use, but for cosecant, it's the opposite idea. We know that it's actually the hypotenuse over the opposite, which means that's equal to root 2 over 1. Essentially, actual values or exact values for these two, you can kind of just get to the point of evaluating. As we go through this, root 2 over 1 is just root 2. So we have a radical plus 3. You could call the coefficient 3 over 2, or you could call it 3 times root 3 over 2. It's completely up to you. But we have to add these. And in order to add them, we need a common denominator, right? So because this is over 1, I'm going to multiply both the top and the bottom of this fraction by the value of 2. And that way we'll have a common denominator. So now we're left with 2 root 2 plus 3 root 3. And all of that is over just the value of 2. Because they're both 2, we can put them both over there. We can look at the radicals and see if we can get any like terms if we combine them, but we can't. This is root 2, this is root 3. So this would be the simplified version. So this would be your exact value. Kind of like when you're in a quadratic formula and you get to a root, you can either start building decimals or you can leave it as an exact value. And this would be our exact value for this example.